Good morning. I welcome you all for this lecture series. Today we have a very good topic in power transmission. So gears plays a very important role in power transmission. So measuring gear parameters is very important when we consider the quality of the gear. So gear measurement ensuring precision and efficiency. It is a critical process in manufacturing, ensuring the production of high quality components that meet stringent industry standards. And this presentation will explore the key aspects of gear geometry, measurement techniques, inspection equipment, and data analysis to optimize gear manufacturing process. So, understanding gear geometry, we have gear profiles, gear dimensions, gear tooth geometry. So explore the different gear tooth profiles such as involute, cycloid, and straight-sided and their impact on gear performance. So normally when the teeth are straight, we call it as spur gear. And when there is a angle, we call it as helical gears that we'll see in the upcoming slides. So gear dimensions are like understanding the critical dimensions of gears, including pitch, addendum, dedendum, and pressure angle, and how they affect gear function. So we all know what is meant by pitch. Pitch is nothing but the distance between two successive teeth of a gear. So we have a pitch circle diameter connecting all the dots of the center point, and the distance above the pitch circle to the top land, we call it as addendum. To distance below the center point and the land, we call it as dedendum. Pressure angle is the angle of approach of one gear with meshing with other gear. And these are the important critical parameters that will take account of the efficient functioning of gear. So examining the complex geometry of gear teeth, including their shape, size, and distribution, and how these factors contribute to gear efficiency and durability. So the inside diameter, outside diameter, and pitch circle diameter, and size of the gear, whether it is a larger gear or higher power transmission, we have higher gear ratios, and the shape of the gear is very important for durability and gear efficiency. So we have three kinds of gear measurement techniques. One is with the coordinate measuring machine, high accurate measurements of gear dimensions and profiles using advanced coordinate measuring technology, and a gear rolling test, evaluating the gear tooth profile and pitch by rolling the gear against reference gear as master gear. Precision measurement of gear tooth characteristics using specialized inspection equipment and software. So gear inspection equipment, we have gear measuring instruments like gear tooth vernier, micrometers, and dial indicators for measuring basic gear dimensions and tooth characteristics. Gear tooth vernier will directly measure the gear tooth thickness as well as the distance from the land to the top of the gear surface, teeth surface. And we have micrometers also to measure the circularity of the gears, and dial indicators. And optical comparators are the projecting magnified images of gear teeth for detailed profile and dimension analysis. This is usually applied in your normal analog watches, where we use very small gear that is made up of stamping. And the laser scanning systems, we have high resolution 3D scanning of gear surfaces to capture complex geometry and detect defects. So gear rolling testers, specialized equipment that have evaluates gear tooth profile, pitch, and run out by simulating gear mesh. Measuring gear tooth characteristics, that is tooth thickness, tooth profile, and tooth spacing. Gear tolerance and quality standards. So precision grade, tolerance limits, quality assurance are the three things that we are going to see in this slide. Gear tooth accuracy and surface finish requirements based on industry standards. Acceptable ranges for gear dimensions, tooth profiles, and runout to ensure proper function. Comprehensive inspection and testing procedures to validate gear performance and reliability. So data connection analysis, systematic measurements, capturing detailed gear measurement data using advanced software and database systems. Statistical analysis like leveraging data analytics to identify trends, defects, and detect defects and optimize manufacturing process. Quality control, utilizing measurement data to maintain tight quality standards and ensure consistent gear performance. So optimizing gear manufacturing is 20% we have to reduce the scrap and 15% the efficiency will get enhanced and 35% improving quality. I hope you all understood what is the gears and the beautiful pictures in the slide. Thank you for your patient listening. Thank you.